I want to make two comments about problem 4. In this problem, we knew the three sides of a triangle ABC, and we were asked to find the angles of the triangle. Over here, you can see the way I solved it. I applied the second version of the cosine law to find the value of the largest angle, C, and then I apply again the second version of the cosine law to find the angle B, that was the smallest one. And then I use the fact that the sum of the angles is 180 to find the third angle A. My first comment is about the rounding over here. You may notice that if you sum the three angles as I have them here, C, B, and A, the sum is going to be 180.1 degrees, and you may be wondering if that's wrong because, well, the sum should be 180. First of all, 180.1 to three significant figures is 180, so that's okay. But why is that one decimal discrepancy over here? That's due to the fact that here when I wrote B, I didn't type in my calculator 40.0 degrees. I used the same value I had in the calculator, that was 39.98 and blah blah blah, kept going. And the same for the value of C. I didn't write 88.3. I used the value that I had saved in the calculator and it was 88.26 blah blah blah. So these values over here are not exactly the ones that we wrote as the approximations in the red boxes. And that's why we get a value that is one decimal off if we sum the triangles. But that's totally okay. We did the correct thing over here. We wrote all results approximated to three significant figures, and we use the same values of the calculator when we needed to use the values and not the approximate ones. Okay, but that's not the most important I want to comment on. Actually, I want to comment on different ways of solving this problem. So let's say we started differently. We applied the cosine law in the second version to find the value of the angle at B over here. And then we could apply the sine law. We could say that, for instance, sine of C divided by 14 has to be the same as sine of B, the value we have over here that is approximated by 40.0, divided by 9. That's the side in front of B. If we do so, then we need to find C. We need to apply the sine inverse to sine of B times 14 times 9. And if we do so with our calculator, the result we get is 88.26 blah blah. This approximates to 88.3. So the same we got before. Now, some of you at this point try to see if there was another possibility. So if it could be that the angle at C is equal to actually 180 minus the result we got over here, 88.26 approximate degrees. I understand why you did that is because we are applying the sine law. And then we are finding the inverse of the sine function. And we know that even though there are two angles that are going to have the same sign, that is sine of B times 14 divided by 9, the calculator is going to only tell us the angle that is below 90 degrees. In this case, just a little bit below 90 degrees. So there will be also the option of this angle being a little bit above 90 degrees, and that would be 91.7 degrees. But in this case, there is no possible second solution because there is only one triangle that verifies having the sides 9, 14, and 11. Once we have these three measurements, we cannot have two triangles. And we know that because we know that three sides determine a unique up to congruence triangle. So the question could be, well, okay, but how do we know that that unique triangle is the one with 88.3 and it's not the one with 91.3? And that's in fact a very good question. So what I did was to use GeoGebra to draw a triangle that has sides 9, 11, and 14. We know the procedure for this. You can start by any one of the two sides, let's say the 14 one. Then in one of the vertices, one of the endpoints of 14, you need to draw a circle with radius 9. And then in the other one, a circle with radius 11, and then find a point of intersection. So I got this triangle, and then I measured the angles, and I saw that actually they are the ones I was expecting from my initial solution. In general, if you're in a situation like this, what you will need to know is whether the triangle is acute or obtuse. This was not given explicitly in the problem, but the pictures suggested so, that only the acute solution was the good one. So, to summarize, this is a bit complicated situation because from the point of view of our knowledge of the sine law, we may think that there are two solutions. But on the other hand, we are sure that there is only one solution because the triangle is totally determined once we fix the measure of the three sides. So the question is, which one of the two possible solutions, if we apply the sine law, should we get? And the question should tell you or should show you in the picture whether the triangle has an angle that is more than 90 degrees or not, whether the triangle is obtuse or acute. In this case, the picture looks like an acute triangle. It will be more precise to write next to it the triangle is acute, and then that way you know that the only possible solution for this triangle is the one that we have over here.